You have your way, and it's making me weaken. You and your status, walking like that. It's really getting too much, but I can't pull back. Though I try to resist, I can't fight this. And no one makes me feel like you do. And no one sets my body on fire. And no one gives me shivers like you. Oh, no one does it better. How I try to sleep, but you're deep in my mind. Got a hold of me. When I'm awake, I'm all blind. You and your magic, like infinite power. God knows I try to resist, but you're pulling me closer. Oh, I gotta stay away, but you won't let me. No one makes me feel like you do. And no one sets my body on fire. And no one gives me shivers like you. Oh, no one does it better.
Welcome to IET Savoy Place, and welcome to you if you're joining us on the live stream. I'm Ramesh Patel, your host for today. I'm also the chair of the Central London Network, and in that network, we're a group of volunteers that organise monthly events which promote the IET's values that are to inform, inspire, and influence. Just like today's session, which is on the topic of sustainability within the new circular economy. Before we get to our speakers for today, we just need to run through some housekeeping. So, firstly, there are no planned fire alarms for today, so if it does trigger, you need to follow the exit signs. You come out the building, you look left, and there's an iron bridge, and that's the assembly point. Secondly, please take this opportunity to switch your phones into silent mode, but don't switch them off because we want you to share across social media. And as a GDPR notice, please be aware this session is being recorded, including the Q&A session at the end. So if you do not wish to be recorded, then you can ask your questions to the speakers outside of Q&A during the networking session taking place in the members' lounge where we just had registration. There's also going to be a cash bar available. Now, the members' lounge is not usually open in the evenings, so it's been made available for you today. So please feel free to walk around and look at the facilities that are available to you as a member of the IET. So, today's evening lecture will be given by Skillcorn founders Paul Skillcorn and Manu Vannan. Paul Skillcorn is a leading international development expert and highly qualified wastewater, food, materials, and renewable energy professional. Manu Vannan has over 40 years of experience in international banking, government finance, and climate change solutions. His efforts have facilitated over 1 billion in funding for various diverse infrastructure projects. So, with that, please give a big round of applause to our speakers for today. Paul.
Thank you. Okay. We got a crowd here today. Thank you all for coming. I'm, as you introduced, Paul Skillcorn. My partner is Money here in the front, and we will see both of us should be up here during Q&A. So let me commence by again thanking IET for giving us this opportunity to present the new circular economy, sustainability redefined. So think that one through, sustainability redefined. I want thoughts on this towards the end or at the end. Our purpose here today is to introduce you to the new circular economy, the problems it addresses, and the solutions it delivers. In the process of doing so, we'll also examine in some depth the underlying technologies and put some numbers and attendant costs and benefits on the technologies as well. Here in this opening slide is an image showing 4 of the 5 genera that comprise the Lemnaceae family. Now, I like to use Lemnaceae, but it's commonly known as duckweeds, and I was told today it doesn't sound good, so Lemnaceae. A family of extraordinary plants that really are the inner engine of the new circular economy. They produce more of a better protein than any other plant, stunning plant, while also delivering more starch, minerals, and vitamins on a footprint basis than any other plant or combination of plants. Get to love this plant. The circular economy has in recent years become a fashionable buzzword that loosely accompanies sustainable development and climate change mitigation in the media and in public discourse. This has also brought it into the political and public policy arenas as a direction being promoted by governments and NGOs alike. In 2010, the Ellen MacArthur Foundation was established with the explicit mission of promoting the new circular economy, the circular economy, forget the new in that one, which along with the World Economic Forum they define as, and I quote here, a circular economy is an industrial system that is restorative or regenerative by intention and design. It replaces the end-of-life concept with restoration, shifts towards the use of renewable energy, eliminates the use of toxic chemicals which impair reuse, and aims for the elimination of waste through the superior design of materials, products, systems, and, within this, business models. While Ellen MacArthur's circular economy is, candidly, more semantics than reality, in the recent G20 summit, India's Prime Minister Modi took the global lead when he introduced Article 37 of the G20 Leaders' Declaration. And I quote here again, we acknowledge the critical role played by the circular economy, extended producer responsibility, and resource efficiency in achieving development, end of quote. I like that. I like that this is being talked about at that level now. Which brings us to the new circular economy. So forgive me using the royal we. I'll do this throughout today. We take free wastes of all kinds, but with a preference for volatile wastes, and we break them down patiently and effectively. We extract all the inherent energy and nutrients in usable form, all the energy and nutrients in usable form, and render the attendant water absolutely potable. I stress that. We use this abundant energy, nutrients, and pure water to produce a range of intermediate value streams and then massively leverage those with free solar photons and free solar thermal energy to locally produce a broad spectrum of superior value-added products and services. We provide many high-paying local jobs, and we share equity with local land and infrastructure providers, and also with local governments, all designed to bestow high income and wealth on our partnering local communities through multipliers that can exceed 7x. This stimulates increasing consumption and increasing waste. The new circular economy encompasses all human habitation, all farming operations, and all mining and industrial liquid and volatile wastes, all. We join with our clients and our partners, and collectively we are the new circular economy. That's the definition. For the next 30 or so slides, I'm going to move quickly to lay out this problem we are addressing. These will provide context. Now, this is the problem we are addressing. These are the problems we solve. Many of the images I'll show were produced at my request by DALL-E. I've been playing around with ChatGPT. Is the image machine of ChatGPT. They are intended to get the point across and should not be considered precise. They are more expressive. Globally, we have a problem with accelerating human aggregation. What took 100 years in the West to develop, moving from the countryside into big villages, big towns, big cities, is now taking place in Asia, Africa, and Latin America in a couple of decades. Everything is accelerating. The problem is universal. In India and Nigeria, what were still called villages can have populations that exceed 50,000. In Liberia, which provides little in the way of services, half the country's population now lives in the greater Monrovia area. This exploding aggregation of humans and animals, fish and poultry grown to feed them, has its consequences. This list is one that we're all familiar with. Global warming and climate change, food security and nutrition, shortages of household water, tightening agricultural landscapes, fertilizers, coal-fired power plants, building materials, waste plastics, waste paper, aquatic pollution, volatile wastes, toxic wastes, and ultimately the massive costs incurred dealing with climate change and effective treatment and disposal of these wastes. The new circular economy addresses this entire list, and we believe more effectively than any current best practices. As we've noted, it all begins with wastes. Wastes are the bread and butter of the new circular economy. The dump, the landfill, one finds these literally everywhere. They are considered problematic for scores of reasons. The new circular economy deals with landfills and dumps and associated water effectively and profitably. Raw sewage, partially treated sewage, drainage, and storm flow in filthy drains, filthy canals, and filthy rivers and streams. Again, we find these everywhere. This, too, is a new circular economy sweet spot. When it comes to rivers, we make a special point here in Greater Delhi, now the world's largest city. Here in Wazirabad, the infamous Najafgarh drain complex dumps into the Yamuna River. Note the black, which comes to dominate everything downstream for hundreds of kilometers. The Yamuna River, as it passes through Delhi, in fact, rejuvenating rivers, which have been the lifeblood of thousands of communities worldwide, is a new circular economy focal point. We'd like to be invited to Delhi to address this problem, yes, by Prime Minister Modi. A swine complex in eastern North Carolina. In a 6-county region, the avian, swine, and, well, basically avian and swine equivalent, and waste produced by avian and swine, produce the equivalent of a human population of 70 million. This is in 6 small counties. And all of it is very poorly treated. Rivers in the region are overwhelmed, and the bay into which they flow is an absolute dead zone. Poultry wastes in modern eastern North Carolina facility being readied for waste gets dumped. The final piece of the eastern North Carolina waste triad, here, turkey waste, simply dumped. We move from North Carolina to North Lagos, Nigeria. Here is a scene identical to what happens in Côte d'Ivoire, Ghana, Cameroon, Uganda, Kenya, Pakistan, India, Malaysia, Philippines, and beyond. The layer wastes are simply dumped when they become overwhelming. Nothing is treated. Everyone wants the eggs. A dairy farm in Tulare, California. This absolutely minimalist treatment system ensures that nitrates in the local groundwater have moved above 100 milligrams per liter. Nothing is being done to correct it. In fact, we are on the verge of blue baby syndrome, nitrate poisoning, becoming endemic in the California Central Valley. A Texas feedlot, nothing treated, nothing recovered. Salinized acreage in Peru, the world's finest place to grow high-value produce. This is a consequence of overusing agricultural drainage water, and or not building proper drainage into irrigated acreage. Globally, salinization has rendered tens of millions of hectares of irrigated acreage non-productive everywhere. This too is a sweet spot for the new circular economy. Saudi Arabia has spent hundreds of billions over the last 30 years creating this particular circumstance, which is quite unique, where center pivots use brackish groundwater to irrigate wheat, primarily wheat, all in the name of food security. They have in the process used up over 70% of their precious reserves of water. This is another sweet spot for the new circular economy. Using less than 2% of the water employed in center pivot irrigation of low-valued, poorly performing wheat to produce much higher tonnage of high-protein lemnaceae, while in the process profitably desalinating some of that groundwater to supply local towns and cities. A truly sustainable value improvement of more than 100-fold. Bauxite processing red mud residuals in Germany. The Saudis have their fair share of this problem as well. The value embedded in red mud, billions of tons of which exist globally, is massive. The solution to this one is not trivial, but it is certainly doable. Informal gold mining wastes in Brazil. The new circular economy can profitably deal with both the suspended solids and the mercury, while revivifying the damaged lands, streams, and rivers. Informal gold mining in Peru. If you're using water, we can make it profitable to do so responsibly. Formal gold mining in Liberia. The new circular economy can deal effectively with both the water and the cyanide in that water, while bringing enhanced value to surrounding villagers who are now negatively affected by these wastes. Toxic coal mine wastes in South Africa. We solved this problem. Toxic coal washery wastes in eastern India. Here too, a profitable solution that renders the water potable. Textile industry wastes in El Salvador. Instead of zero liquid discharge, we can take this effluent and render it potable as well. Abundant tannery wastes in the Buriganga River, downtown Dhaka, Bangladesh. Chromium is something we handle profitably and very effectively. Sugar mill wastes in North India, ubiquitous and dealt with very poorly. Corn ethanol wastes in Nebraska, United States, polluting the groundwater and occasionally local streams and rivers, poorly treated at best. Central Brazil, cane ethanol vinasse, gradually destroying hundreds of thousands of hectares of once good land, a story that's not been told. Malaysia, palm oil processing POM wastes, toxic, untreated discharge. A large coal-fired power plant. These are literally everywhere, causing massive pollution of the atmosphere, rivers, and groundwater. And with billions of tons of fly ash residual that is poorly maintained, poorly handled, and very poorly disposed of. Cleaning up and repurposing these facilities when they are decommissioned is done very poorly. Try South Africa. This is another new circular economy sweet spot. Coastal area permanent flooding, an increasing consequence of climate change and the rising oceans. Hundreds of millions of people in places like Bangladesh, India, Pakistan, Sri Lanka, just to mention South Asia, are already being affected. Again, a new circular economy sweet spot. Here in England, waste treatment and disposal has been getting a lot of recent bad press. We're in the UK, and we'd love to get involved with developing a fix for this growing problem. A fix that will actually be profitable for all concerned. And the list goes on endlessly. Paper mills, food processing plants, oil mills, petroleum refineries, chemical plants, ports, airports, rail yards, manufacturing facilities of every kind, all can benefit from the new circular economy. Here we take a quick look at standard practice in dealing with much of the waste we have just seen. This is a stylized, modern, big box wastewater, activated sludge wastewater treatment plant. The technology at its core is sadly over 100 years old. These systems are very expensive to construct and to operate. New big box systems do not accommodate incremental increases in capacity, so they are always overbuilt. Too expensive. They do not easily accommodate potable reuse and lose virtually all the energy and nutrients inherent in sewage, while themselves burning through massive amounts of electricity. We, by the way, again that royal we, Money and I, provide a new circular economy retrofit to activated sludge plants that increases capacity while also lowering the cost of treatment. This is a stylized, modern anaerobic digester complex. There is general reluctance to invest in and successfully operate anaerobic digesters in large activated sludge plants. There is growing enthusiasm, however, for investing in anaerobic digester plants that pull in mixed volatile solids. The EU leads the way in this. Countries like India are following suit, recently announcing big subsidies. The problem with these systems is that they persist with one big, fully mixed reactor chamber, when the biology is sequential. Excuse me. There have been recent improvements in material breakdown and lysis, notably using high heat and pressure. The big single chamber, however, renders them hopelessly inadequate. CO2 is lost, potential energy is not realized, and the discharged sludge is off-putting, with nutrients not captured in a useful form. Absent subsidies, profitability is marginal. The new circular economy phased sequenced anaerobic digester system deals with all these issues. Advanced waste to energy systems, I had a conversation here earlier, are still an experiment in the making. Neither performance nor reviews have been good, so I'm waiting to see this one improve. Dealing with mixed wet inputs, lignocellulosic materials, and mixed and glass reinforced plastics, plus all the other non-flammable stuff that makes its way into the mix, mud, for instance, has proven difficult to say the least. Emissions, ash and CO2, as well as dealing with the burnt stuff is problematic. Ultimately, there are much better approaches, profitable approaches, to dealing with all these inputs. Advanced composting. We hear this word a lot. Compost this, compost that. A big thumbs down. I used to be a composting advocate, but no longer. Again, there are much better things to be done with what is being composted. There is only one commercial composted product that has survived during the years I've been examining this business. And there are thousands of composted products out there. They all disappear. Milorganite. out of Milwaukee, Wisconsin. Ironically, milorganite is the worst stuff. Composted, desiccated, waste-activated sludge, replete with all the heavy metals and toxins and torques. I use that word quite a bit in coming up, trace organic compounds that are prevalent in Milwaukee's sewage. They have a target market. They address that market effectively and continue to sell it. I applaud them. Big tank mining effluent settling systems. Here we show a likeness of an iron ore mine in Goa, India. Again, a thumbs down. Groundwater and stream flow are damaged and destroyed. There's no treatment of the damaged water chemistry or improvement to landscapes. No income is generated on these damaged landscapes. There are no societal benefits. Tourism is degraded. This can all be done in a better fashion, the new circular economy. Indeed, the new circular economy successfully addresses all these seemingly insoluble problems, and more so. We treat and purify all wastewaters, including septage, allowing complete reuse. We do profitable mineral stripping and desalination of saline and damaged groundwater and agricultural drainage, rendering all to a potable quality. We extract all inherent energy and nutrients. Nothing is lost. These are then leveraged with solar and massively value added. All treated water is rendered to a pure, zero torques, that's trace organic compounds, potable condition that allows consumption by humans and reuse in high-valued applications. Here I've laid out some of the key treatment technologies on the left and some of the key value-added technologies on the right. We have to make money with our system. Excuse me. Treatment of waste, complete patient lysis and hydrolysis, critical. Complete extraction in a profitably useful manner of all energy and all nutrients. Fully automated, high output lemnaceae farming, now being acknowledged as the world's next great supercrop. Lemnaceae polishing, removing all toxin, torques, and metal vectors. No loss of water. Nothing is simply discharged. Superior distributed production of fully integrated and heavily optimized, firm, on-demand, 100% renewable electric power. Value-added monetization. The highest fish production on a footprint basis, done in a distributed fashion and almost anywhere. The highest meat and animal lipids production on a footprint basis, a superior fish meal substitute. We don't have to fish all those anchovies anymore. Arguably the most efficient distributed non-LED vertical production of functionally organic vegetables, herbs, and salad makings, harvested and delivered today. Agrisolar, greenhoused, organic hydroponics. Natural fiber, reinforced organic bioplastics. A structural fiber and engineered wood revolution in a world that is denuding its forests. As you've gathered by now, our new circular economy is a complex system. This slide puts it all together. Nothing shown here, however, is difficult to do. Note that virtually everything circulates through the lemnaceae greenhouses shown in the bottom center. Forget the detail for a moment and look at what we capture coming out of the community of Kuta, a small town in Fayum province, the Garden of Egypt, top left. We have mixed wastewater streams, including sewage, septage, and industrial wastewater. Municipal volatile wastes, basically stinking garbage. Other volatile waste streams such as fish, dairy, avian, and CAFO, concentrated animal feeding operation wastes. We also have dirty, mixed plastic wastes. Now look at the output. All feeding into those wonderful green dollar signs. Organic white fish fillets or fillets and giant prawns. Organic aquaponics produce. Molded bioplastics. Engineered lumber and attendant products such as the domes that we produce. Hydroponic produce such as herbs, vegetables, and vine fruit, all functionally organic. Firm, on-demand, renewable electric power. Recycled, zero-torx, potable water, and captured and stored ambient water. We might also have add, steam, and serve prepared foods. We're trying to do that in India. Superfoods, nutritionally optimized feedstuff, and a range of other value-added products. The devil is, of course, in the detail, and each of these systems incorporates proprietary elements which we must maintain in our black box. In this diagram, we do add some detail. Here we parse much of the top portion of the previous flowchart. This chart is dominated by our phased, sequenced anaerobic digester system, which you've already been introduced to. Here, it is presented across the top half of the flowchart. This chart is dominated, flowchart. We operate a very different, more patient, and much more efficient material breakdown, lysis, and anaerobic digester system that now exists out there in the commercial economy. This system, along with our Lemnacia aquaculture system, is critical in achieving the new circular economy. The difference lies with our persistence in breaking down, lysing, and digesting all volatile materials, and our use of discrete, sequential acidogenesis, acetogenesis, methanogenesis, and methanation reactors, all of which feature our unique carbon donor biofilm. The outputs from our digesters are mineralized grit, which could be used to make fancy paperweights or cornerstones, straight biomethane, and a clarified organic nutrient stream. As you've deduced by now, the Skillicorn system has a lot of moving parts, and it covers a lot of ground. These next 3 slides provide simplified, discrete flow diagrams for 3 critical pieces of the larger new circular economy: water and wastewater, renewable energy, and nutrients. So let's take a look at what's going on in the water arena. This slide assumes the existence of underlying infrastructure, a water supply network, a sewerage network, a stormwater management system. Where these do not exist, an African village or even towns and cities, for example, we are prepared to ensure that these are designed and constructed locally, emphasis on local. In greenfield systems, we operate with small, highly optimized distributed systems, which obviates any requirement for big mains, big pumps, and big concrete box wastewater and water treatment plants. In brownfield circumstances, we typically need to fix and or enhance these underlying infrastructure components in all places where we work. Where activated sludge wastewater treatment plants already exist, we start by retrofitting our MOB systems, that's mobile organic biofilm, on those plants and improving existing structures and apparatus to ensure better flows, less sludging, and adequate aeration. MOB lowers treatment costs, improves treatment efficiencies, and can double treatment plant capacities. We then take that treated to standard wastewater and run it through the pneumatic greenhouses and water processes seen in this flow diagram. There, we strip final nutrients, BOD, COD, heavy metals, targeted toxin vectors, and TORCs. There's that word again, trace organic compounds. This water is then stored in open-topped, shallow tanks into which we place our in-the-water PV power plants. The 2 grades of lemnacia produced in our pneumatic greenhouses are then processed into food and feed products, as well as bioplastics and binders. Once treatment to potable has been reliably demonstrated, we then pilot a partial raw wastewater stream through the screen clarifier shown here and perform complete treatment using, in combination, the Skillicorn lemnacia system and the PSAD, or phase sequence anaerobic digester system. Once our local partners are comfortable that complete wastewater treatment has been reliably demonstrated, the activated sludge plant is mothballed and maintained in that condition for some time as a viable backup system. Eliminate risk. Eventually, it should be decommissioned and disassembled. I would love nothing more than to get rid of all the activated sludge wastewater treatment plants. Here, we feature the renewable energy elements of the new circular economy. The gray boxes show use of waste plastics, which is globally ubiquitous, to produce our molded foamed panels onto which we place our nano PV solar panels. These panels are then placed side by side and end to end into the water to form small, distributed, highly optimized power plants. Small pumps in each panel ensure that the backs of the PV panels are irrigated with cooling water. The tops of the PV panels are also kept spotlessly clean with that same water. Despite being flat in the water, these cooled in the water floating panels can increase PV panel efficiencies as much as 25% over conventionally mounted panels. The foamed plastic panels also serve to completely halt evaporative loss of water. 4 objectives are served. 1, any and all waste plastics, thermoset and thermoplastics, as well as thin film, dirty and foamed plastics, and I've said to my family, yes, dirty doggy bags as well. 2, significantly higher evaporative losses of water are halted completely, absolutely. There's no evaporation of water when it's covered with our systems. Significantly higher PV efficiencies are attained. And 4, good dry land is not dedicated to producing solar power. The land being used is always doing double duty, storing critical supplies of water and producing renewable electric power. The solar power is then stored as H2 and or ammonia, as well as in batteries, typically giving 2 to 3 hours of peaking power. The H2, hydrogen, is blended 50-50 with the methane produced in the PSAD system and run through a distributed array of small CHP, that's combined heat and power, configured capstone gas turbines. These systems are used to ensure 24/7 supply of firm, on-demand, 100% renewable electric power. The exhaust is captured, heat is extracted for the PSAD systems as well as greenhouse heating and Lemnacia desiccation. Some of the gas is diffused into the Lemnacia tanks, while the balance is employed in supplying CO2 to proximate hydroponically irrigated agrisolar and three-dome greenhouse facilities. This greatly increases CO2 in both the water and the confined atmosphere above the Lemnacia, which can photosynthetically extract CO2 from both the air and the water. And these plants are unbelievably responsive to increased availability of CO2, perhaps more so than any other vascular plants. Note that we submit our already high methane and low CO2 biogas to a final discrete bacterial methanation step that is infused with some of our electrolysis H2, hydrogen, and whatever residual CO2 may be available. Note also that we have very high immediately local use for all the O2, oxygen product, of our green electrolysis. Our fish and prawns need oxygen. We are open to using the catalytic green ammonia processes now being piloted and optimized around the world, and using all that ammonia locally as either fertilizers and or fuel for efficient linear generators. Everything is distributed, local, and highly optimized. Our nutrient flow diagram mirrors, but from a nutrient perspective, the water and energy diagrams. We derive our nutrients from all the free wastes we are given, some liquid and some solid, most with tipping fees and treatment fees attached, free and subsidized. Dissolved waste in sewage passed directly to our Lemnacia pneumatic greenhouses as a clarified fluid. All those nutrients are taken up by the Lemnacia plants. Solid wastes are patiently broken down, fully lysed, and all inherent nutrients are carefully extracted using our PSAD units. Some of these extracted nutrients are fed to our Lemnacia, and some are fed to plants grown in our agrisolar and three-dome greenhouses. We are able to parse our clarified nutrients to some extent and use them to deliver precise life cycle nutrient combinations to the many salad makings, specialty vegetables, herbs, and vine fruits we grow in those systems. Where a surplus exists, we can use it in buried drip fertigation irrigation of our two main fiber crops, Arundodonax and Canaf. We will never sell our nutrients on the outside, never. All of it is used internally, all is functionally organic. So, what do these flow charts take in and what do they actually produce? We describe this in three simple lists: inputs, intermediate value streams, and value-added outputs. The beauty of this new circular economy system is that literally all inputs are not only free, but except for the seawater, brought to us and heavily subsidized. And all the final output products and services are high-priced and value-added. We prefer to avoid selling the intermediate value streams. Everything, where possible, should be solar leveraged, massively value-added, producing high-quality foods within a metro area, and then delivering it as harvested and delivered today, while offering clients, come kick the tires, we're right here, has immeasurable value. Demand for 100% renewable electric power that is firm and on demand is extraordinarily high. Nobody is producing it, and everybody wants it. This power can be wheeled to global clients like Google, Microsoft, Amazon, and Apple at affordable rates. The local availability of huge quantities of pure, zero torques, is that word again, potable water, water that is better than any local tap water is similarly valuable, notably when virtually every city and town worldwide is preoccupied with being able to supply drinking water to the future, in the future, to their exploding populations. Mumbai, to pick a place, is dumping stunning quantities of raw wastewater 2 kilometers off its western coast at Bandra, while desperately seeking new supplies of water near Nashik, 300 kilometers to the northwest. In a world where forests are being rapidly felled, the value of high-quality building materials will only continue to soar upward. Having the very best engineered lumber products available locally is invaluable, anywhere and everywhere. Despite global commitments to reduce production of petroleum products, demand for plastics of all kinds continues to grow inexorably, notably in places like Africa that have not yet had the same levels of access as populations in the West. Prices are, accordingly, continuing to climb. Performance of our natural fiber reinforced bioplastic copolymers is comparable to glass reinforced petroplastics, and they can be used in manufacture of robust vessels used in the harvesting, manufacture, and storage of food and its derivative products, where glass fiber, for instance, is forbidden. In a world struggling desperately to provide all its citizens with enough protein, minerals, and vitamins, Lemnacia-derived superfoods that can be grown anywhere, deserts, flooded landscapes, or vertically in places like Singapore, London, Helsinki, Riyadh, or Hong Kong, hold the solution. Here we look at the marginal numbers behind a commitment to allocate 1 hectare, approximately 2.5 acres, to the new circular economy. A 2D, two-dimensional manifestation of the new circular economy. As I mentioned earlier, we can go vertical in high-density urban areas, but here we're talking 2D. The numbers shown here are done on a per hectare basis, but they assume a scaled system comprising at least 10 hectares, one capable of treating to a potable quality at least 1.1 cubic meters of million cubic meters of conventional raw sewage. CapEx comes in at around $3 million for a conventional 10-hectare system capable of treating 3 MLD, 3 million liters per day, of raw sewage. That's a simple rule of thumb. $1 million and 3.3 hectares of land per MLD. 1 million, 3.3 hectares, 1 MLD. So this is a complete system. Water, nutrients, and value added. On the energy side of the equation, we're talking projected revenues of $136,000 per hectare. That's 1.36 million for a 10-hectare, 3 MLD system, and with gross margins of around 50%. On the value-added side of the equation, we project 1.5 million in gross revenues and even higher gross margins of 65%. This kind of profitability for a wastewater treatment plant absent fee revenues is simply unprecedented. Depending on how you count your shekels, whether you borrow or pay cash, we're talking about a project internal rate of return of between 30 and 70%. Extraordinary. 3 Skillicorn system technology packages lie at the core of the new circular economy. Carbon donor biofilm employed in activated sludge MOB retrofits, soluble BOD reactors, phased sequenced anaerobic digesters. the Lemnaceae family of superplants, 2D nutrient removal and farming, 3D nutrient removal and farming, and polishing toxin and heavy metals removal. The three-dome system, it's just my term, we did this initially with 3 domes. Advanced aquaculture, vertically arrayed natural light agriculture, vertically arrayed automatic aquatic vermiculture. The Canaf plant, a hyacinth variety, is a truly extraordinary plant that has long been forgotten in the hype surrounding legalization of hemp, which is an inferior fiber plant. Canaf is more productive than hemp. It has a comparable bast fiber, the long stringy fiber in the plant's bark, but it is the plant's core or stick that truly defines the value of the Canaf plant. Canaf core is the most structurally complex lignocellulosic material in existence, vastly more so than better known balsa wood, for example. The surface area of Canaf core is comparable to a middling activated carbon. But unlike activated carbon, every pore communicates with every surrounding pore. Further, the ratio of lignin to cellulose and hemicellulose is much lower than any other structural fiber. These 2 factors make the plant more available to bacterial colonization than any other, notably in circumstances where nitrogen to carbon ratios are high, such as septage and primary wastewater and wastewater primary and secondary solids. Canaf core allows us to make much better use of bacteria in activated sludge, much better. In anaerobic digestion, soluble BOD removal, and a number of other circumstances. It also provides us with an inexpensive analog to activated carbon in circumstances where highly efficient absorption and adsorption are critical. Canaf core absorbs oil more effectively than any other material, and it does so preferentially to water. Think of oil spills. While initially hydrophilic, it will, once wetted, absorb more water than any other plant material. These characteristics are unique and lend themselves to a variety of extraordinary applications. We have developed highly efficient, unique approaches to planting, fertilizing, growing, and harvesting Canaf, storing it, processing it, and packaging it. We multiply Canaf seeds, produce Canaf oil, among the most penetrating oils known to exist. It has extraordinary medical, pharmaceutical, and cosmetic applications. And use the resulting Canaf meal nutritionally. We use the ultra-strong Canaf bast fiber to reinforce our unique bioplastic copolymers and lend those plastics extraordinary UV-resistant characteristics. I was telling a gentleman here, you can take a bucket, a polyethylene or polypropylene bucket, leave it in the sun for 3 years and it will disintegrate. You can take a Canaf reinforced bucket made with bioplastics and it'll stay there for 10 years, no problem. Bottom line, it is Canaf's extraordinary ability to provide easy carbon to bacteria surrounded by high nitrogen media, and to be able to do so with stunning surface area that is Canaf's most valuable characteristic. Time is short. We can discuss the specifics of our Canaf applications, MOB systems, soluble BOD reactors, phase-sequenced anaerobic digesters, bioplastics, and engineered lumbers in Q&A. Let me move directly to the engine of the new circular economy. Here are some common species we've worked with over the last 50 years. Lemnaceae grow literally everywhere. Siberia, Saudi Arabia. My favorite is El Peruano, Lemna gibba. Within Peru, strains have evolved magnificently to optimize growth in always cold in the summer Lake Titicaca, cool in the summer Lima shoreline, and hot in the summer Lambayeque interior. Mixing these three and increasing CO2 availability anywhere in Peru and similar latitudes in other countries produces extraordinary output year-round. There is growing agreement that Lemnaceae can potentially achieve dry weight production volumes up to 120 tons per hectare. We're headed in that direction. This has been repeatedly demonstrated in the laboratory. Compare that with soybeans, which now occupy close to 200 million hectares of production acreage worldwide, and at the best produce 5 tons per hectare, and have somewhat lower levels of an inferior protein, and nowhere near the levels of minerals and vitamins that are delivered by Lemnaceae. Demand for soy meal and soy protein extracts is leading to stripping of the Amazon rainforest in Brazil, in Bolivia, and yes, Peru. We hear of super algae crops like spirulina and chlorella. Lemnaceae is nutritionally superior. They are now being rightfully recognized as the world's next great supercrop. NASA is even doing a lot of work with Lemnaceae as a mechanism by which to create their own circular economy in space. Lots of work. Several companies are working with venture capital funding to produce protein extracts and concentrates for direct human consumption. Others are looking to bring large-scale mechanized production of Lemnaceae species into supermarkets, and several groups are offering in-the-kitchen units that can give you a bowl fill at the flip of a switch. I have been working with Lemnaceae in India, Bangladesh, Mexico, the US, and Peru since the 1970s, long in the tooth. We developed the first Lemnaceae cropping systems. We are the first to have used Lemnaceae as an engine in the profitable treatment, emphasis profitable, of wastewater. Indeed, our Mirzapur wastewater treatment plant in Bangladesh operated continuously for 30 years, paying for itself 7 times over despite giving away half of its output while treating wastewater to a quaternary standard, almost potable standard. Today, we have moved far beyond what we did then. Going vertical is the ticket in densely populated urban areas. We are doing that. A little history. This is the interior of the first Lemnaceae greenhouse I developed. Here, cleaning swine effluent on an intensive hog farm in Snow Hill, North Carolina, back in the 90s. It was very effective, and it produced copious amounts of high protein, high starch, high minerals, and vitamins feedstuff that we then fed to broilers, turkeys, and the swine themselves. Note the very dense duckweed, Lemnaceae mat. In this instance, a combination of Lemna minor and a local Wolffia strain. This works to ensure the absence of algae, which are always problematic when they invade our systems. There always has to be a complete cover. I took this system to Smithfield Farms' Joe Luter, who then controlled the swine industry in North Carolina. He rejected it because it was, to quote him, too effective. He explained that he was now amortizing a several billion-dollar investment and did not want to be forced to spend another couple of billion on wastewater treatment solutions. He went on to warn me that I should stop pushing this solution in the US, or to quote him again, bad things will happen. Joe cashed out with a $4.72 billion sale of Smithfield Foods to the Chinese Shuanghui Group It remains today the largest sale of any American company to the Chinese. And just a quick note on our unique three-dome system. The three-dome system produces a continuous harvest of fish, giant prawns, and one produce crop in any given dome at any given time. It can do all kinds of crops, but only one at a time. And it's a continuous system. Salad making, specialty vegetables or herbs, and these are delivered fresh, absolutely fresh, to local clients. The slogan, harvested and delivered to you today. All systems here are harvested continuously. The aquaculture system built into the bottom features no buildup of nitrates. Water is continuously treated and rendered absolutely fresh and heavily oxygenated when returned following treatment. We treat it with lemnaceum. It features low energy use to always maintain an exact temperature. The dorsal iris aperture controlled thermal draw provides cooling, and the domed greenhouse with an aquaculture water thermal sink provides heating. A groundwater heat pump provides additional heating or cooling to that water as necessary. The easily assembled dodecahedron geodesic dome is made from ultra-strong, 100% natural engineered lumber that's been ossified. Manufactured using lemnacea binders and MG-treated STL, Skillicorn Technologies Limited, grown arundodonax and reinforced canaf bast fibers, reinforcing canaf bast fibers. We also use it to produce our floating 3-story homes. This image speaks for itself. We are confident that this is about to begin happening. A little history. Each of these projects was a compelling project, and each taught us a lot of lessons. In Hookerton, after demonstrating success, we encountered the establishment head-on and were persuaded to retreat. Books need to be written on Hookerton. I got to write that book, Bob. In Las Animas, after demonstrating profitable wastewater treatment and profitable phytodesalination, ironically paid for by a Republican governor's office, the change to a Democratic governor simply wiped the slate clean. The new guy simply wanted everything gone, clean slate. In Peru, I missed that one. Anyway, this is Las Animas. In Peru, after demonstrating extraordinary success with an association of landless women who built and owned the project, constructed on salinized, unproductive land leased from local farmers, the project died when the farmers insisted on increasing their lease revenues tenfold. When the Canadians who funded the project refused any assistance to farmers whom they considered to be relatively wealthy, negotiations between the Women's Association and the farmers broke down. And the farmers came in and bulldozed the project one Sunday morning. Gone. In Bangladesh, the Mirzapur project, shown here, operated successfully from 1988 through 2015, despite a change in management of the Kumudini Welfare Trust, one of the few Hindu institutions in that country. When Indian Prime Minister Modi visited Mirzapur that year, he donated a brand new Indian-built Wabag, Swiss design, activated sludge package plant to the Kumudini Hospital complex. How could they refuse? Where the Lemnacea facility had for over 30 years supplied Kumudini with all its fish requirements and produced a quaternary treated effluent throughout, better than anything in Tokyo during that period. The Wabag facility cost significant amounts of money to run, produced much lower quality treated effluent, and it supplied literally nothing to the community. It reportedly no longer functions. Discussions on new circular economy systems are engaged worldwide. To pick a place, we're having several promising conversations in Saudi Arabia. This, ironically, is a spreadsheet supplied to us by them, pointing out the enormous potential for wastewater treatment in parts of that country. This data ignores the even larger potential for brackish water desalination, something that could turn the entire country green while using very little of their precious groundwater. As noted earlier, an invaluable resource they have squandered on growing wheat that is low valued and unproductive over the last several decades. Here's where all our discussions are headed. We are hopeful that we will begin commencing work on select demo projects in a number of countries by the end of the year. This is typical of the path that must be followed in any new location. So we come to sustainability. Sustainability redefined, question mark. We define sustainability as moving equitably into an uncertain future without destroying ourselves as a species, minimizing damage to other species, and doing so while also preserving and enhancing the planet that supports us. Draw your own conclusions. Question time. Thank you. Appreciate it. Money. Oh, we're good?
Yeah.
All right.
Thank you very much, Paul. That was absolutely fascinating. So let's jump straight into Q&A. Please keep your questions brief. If you have any in-depth questions, we have a networking session afterwards, and you can grab Paul or Manny afterwards to ask those. So, yeah, jump straight in.
Thank you very much. Thank you very much for your talk. Very enlightening. So, one comment you made, I said waste to energy. We've got a plant being developed in East Europe that will take green waste and convert to syngas, then to energy. I like what you've said about, you talk about desalination and capturing the sewage. What stage are you in the UK? I mean, have you got a test site or planning a test site? What stage are you?
No, we don't have any, sites in the UK, but we are working on sites in Ireland, and we are starting a project in Egypt in Fayoum Governorate, and also we will be shortly starting our commercial project in Liberia in Buchanan for one of the biggest mining companies there, and also project in Kuala Lumpur for the Kuala Lumpur International Airport, and also in India 3 projects, one in Goa, Jodhpur, and in Chennai.
Okay, thank you.
Just a reminder that we are being recorded, so if you don't wish to be recorded, then please grab them afterwards in the networking session.
Given how good CANAF is from what you described, all its properties, why has it been overlooked until now? Why has CANAF been overlooked until now?
I'm puzzled. Hemp is the sexy fiber, in a sense. CANAF was, for many years, grown in Japan, in particular, as a special crop. So Japanese school children were introduced to CANAF everywhere. They used the long fiber to manufacture cloth that is special cloth. Nobody used the core, the inner core, which to me is 100 times more valuable than the long fiber. So it's one bast fiber. Jute is a bast fiber. CANAF is a bast fiber. And they think of it as bast fiber, and that's about it. So hopefully, and not hopefully, it will certainly change.
Paul, a question for you. And return on investment on the project itself, you said 16% on one of your presentation. What is the return on investment on the whole project?
mean, our internal rate of return, we project anywhere from 35 to 70%. Our contention is that if you have a factory producing whatever, treatment of the wastes will be more profitable than whatever it is that you're producing.
Thank you.
Do you have any questions from YouTube as well? No, nothing online.
Thank you very much for your presentation. Obviously, lamnaceae seem to be quite powerful and useful, as well as canaf. It might be early days right now, but have you any plans for how to handle possibly them becoming such great crops that they become the next palm oil, where trees are felled to grow canaf and lamnaceae?
Yes, I mean, one of the contentious issues is, well, we only have so much land here for wastewater treatment. And my point is simply, look around you. There's lots of farmland. Discussions in Ireland, for instance, our commitment is that if you're making X per hectare with dairy cattle, for instance, in Ireland, we will increase your income in a joint venture relationship with us, treating wastewater tenfold per hectare committed to this crop. Massively profitable. Agriculture is unfortunately not profitable.
Thank you.
Remember, all our inputs are free with a tipping fee or a treatment fee attached. All our outputs are heavily leveraged with the sun and value added. So it's a good business.
If I can ask one of my own.
Sure.
So you're talking about this as a wastewater treatment solution. For a city the size of London, how would you manage that? I mean, if we're talking actually replacing standard wastewater treatment, what sort of area would you need?
Can I so we can go vertical. Right? So I talked about 2D models in which we use inflated greenhouses, pneumatic greenhouses, very inexpensive infrastructure. But we can go vertical and produce 200 layers, up 300, 400, 500 layers. I mean, every 8 inches, another layer. And while we're not occupying all of that space, if we have a building that occupies a hectare, we can go up with half of that hectare with hundreds of vertical production. And all of this operates with aerosol. So we use aerosol systems. We don't have ponds in which the duckweed or lamnaceae grows. So we're happy to do this anywhere.
But it still hasn't quite answered the question. What sort of area would you expect to take?
I mean, so I can go, how high do you want me to go? We are talking to a group in the States, includes Arup and some architecture firms, and they are talking ridiculously high. So putting in buildings that are as big as your shard to treat wastewater. And the contention again is that it will be massively profitable. Produce pure drinking water. And take a look at wastewater treatment, how it works. There is this issue of large mains, big pumps, and one huge box concrete wastewater treatment plant or water treatment plant. If you can distribute everything and you do away with these big mains, which is a huge savings. I mean, we spend as much on mains and pumps as we do on wastewater treatment plants. Get rid of them. Make it small, distributed. And remember also that the water that you're producing there is going to be better than anything you're drinking in London. I can drink your water here in London, and I will have in that water every drug that I have that's in the hospital. Yeah, it's treated with technology that's 100 years old. Right? We run everything finally through a membrane, but we remove everything before we get to that membrane, and we have some tricks on the membrane side as well. So not much space, and we can do it in all kinds of interesting spots. We're talking to Singapore on that, sort of, we can't, there's no, and I showed them just Orchard Road, 100 spots where we could put a building, not a problem. And I'll do the same in London, not a problem.
Thank you very much. Sorry, can you just wait until the
Continuation to that question, when you are saying a vertical solution, won't that be a sustainable? And how will that be a sustainable when you want to push water up all the way to like a shower type building?
Well, how do you define sustainability?
Means
Yeah,
it does cost energy.
It costs energy to push it up.
Yeah.
And our cost of the Lemnasia system is 3x. We spend going vertical 3 times what we spend on a 2D basic farming model. So it costs more. Pushing water up that high, yes, it costs a bit more, but relatively speaking, not a lot more. If you look at the kind of expense of an activated sludge wastewater treatment plant, pumping all that air into wastewater, they spend 100 times what they would spend taking water up a little bit into the sky. So it's nothing. I mean, relatively speaking, no cost at all.
I think need to understand a bit more.
Yeah, and also, there is a business model here, So there is a revenue model, there is a business model. So as far as we are concerned, wastewater recycling, especially in the context of municipal wastewater, is a profit-making business. So that's the justification. The one reason why, the industries or the cities and municipalities or water utilities are not investing in wastewater treatment, because you come across, Google and find out, all the utilities are discharging raw sewage year after year, and they are being penalized heavily. One of the water companies was, I think, if I remember correct, in 2019, they were handed down some 120 million, for letting out untreated sewage water in the North Sea.
Yeah.
So this is all the public domain. Why they are not doing it? Because you can't blame them. The water companies are working for, the investors. So it's all privatized. So they have to generate, profits. Okay. So the investment in the wastewater treatment plant is a sunk cost. So that's why they want to avoid that, because of the profit motives. So we strongly believe, unless and until the wastewater treatment has a business model, which has a compelling business case, the industry will not adopt any technology. So any technology, if it has a business model, that will be adopted by the industries, the cities and municipalities.
The city where I live, Austin, Texas, today spends $1.5 billion doing municipal solid waste, water treatment, and wastewater treatment. If they adopted our business model, that cost would go away completely, and they would make $1.5 billion. So that's a city of 3 million people would make essentially $3 billion more than they are making today. That kind of income for a city is they can't afford a metro. With that income, they can afford metros. They can afford all kinds of things. So it's critical that every city, every town, every community, everywhere begin doing this. Right? They're just spending money. Let's make some money.
Now, another example, we are now currently working on is in Lesotho. Now the state-owned water company, it is in the red. Okay. Now, what we are providing is a turnaround solution. We said, no problem. We can come in, we can retrofit our system and create a profit, and then help you to come out of this loss-making situation. So this is exactly the business model which we think will drive all the industries, cities and municipalities to adopt innovative technologies like ours. So the future is innovation. Water has no substitute, and we are losing all the water, fresh water supply sources. Okay, and so the water stress is a serious issue globally, and by 2030, half of the world's population will have no access to safe drinking water.
More questions? No?
One more.
Okay.
Keep them coming.
Last
We're
minute.
anxious to
Yeah.
answer questions.
So you mentioned there's one compost product that has survived. What's that used for? And you also mentioned there's value in red mud. What is the value?
What was that? I didn't quite get that.
So you mentioned there's one compost product that
Yeah,
has...
I don't like compost. Yeah.
Yeah, you said
I
there's-
hate compost.
You said there's one compost product that has survived that they,
oh,
that
that
they
one?
sell.
Yes,
Yeah,
that's a stunning product.
What's it used for?
It's called milorganite, and it has been produced for a long, long, long time. It's been it's composted waste-activated sludge, just dirty, nasty stuff. And they developed an efficient, good system to do it, and they have identified markets. I mean, do not use this on food plants and on. But they've developed this market, and they continue to sell it. And I, as I said, I applaud them. But it's the one compost product that's continued. Everything else dies because there's just no value in it. It's very little value. You have to have a sexy product, and the sex appeal disappears, and what do you have? Well, composted. It's supposed to be good. Fertilizer, So compost just doesn't work. And there are much, much, much better things to do with what people compost today.
So who are they selling it to?
I'm sorry?
If you can't use it on food plants, who are they selling it to?
I missed all of that.
If you can't use it on food plants, who are they selling it to?
Oh, they decorative plants in the home, golf courses, these kinds of things. Yeah.
You also mentioned that there is value in the red mud.
I'm sorry, I'm kind
Red
of...
mud, you said there is value in red mud.
In red mud? Oh, yeah. Red mud is got everything in it. So titanium, it's got aluminium, it's got all kinds of good things in it. It's just that the process that is used right now to refine bauxite is, again, 100 years old. And for some reason, the investment in that technology is so massive at the moment that no one has done anything about changing it. Now, there are people out there whom are friends of mine who have processes now that can take red mud and essentially extract all of those values and produce a profitable, make profit from cleaning up the waste. And I'm looking at it as much as anything at cleaning up the waste. You look at places like Dubai and Abu Dhabi, for instance, they have stunning amounts of red mud in that gap between Abu Dhabi and Dubai that is all out there. And it's ridiculous.
what's holding you back at the moment, and what's your investment plan, funding?
I mean, due diligence takes time. We have, for instance, a project in Egypt that we've gone through all the steps. We're talking to all the right people, and they have gone through all the steps. And they have given us a concession. So it's taken 3 years. These things take a long time. And they've done a good job with their due diligence. But Egypt will happen. For us, I mean, Egypt is just ridiculously good. All of that heading from Cairo to the ocean, to the Mediterranean, that triangle is just stunning in terms of value to be had. Incredible.
Another question?
One of the things that gets into wastewater are microfibers from man-made cloth that's been through a washing machine. Is there anything that can be done with that? Because it's getting everywhere. They say the deepest oceans have got it.
Point made. Okay, there's lots of stuff in wastewater. We use a simple continuous screen filter to remove suspended solids. We have systems that have water that's 2.5 feet deep. We get a certain amount of deposition there, but our systems are inexpensive. We can amortize a treatment plant in 5-6 years. And those wastes that may deposit in our lamnasia systems, we will pick up and run those. If they're volatile, we'll run those through an anaerobic digester. I would propose that we do not have recycled paper. I mean, I look at recycling paper, recycling plastic. It's all kind of nonsensical. Nobody recycles plastic. And what paper gets recycled is a minor part of what we put in the recycle bin. I would take all paper and I would grind it up with a large garbage disposal in every house, and I would flush it down the toilet, everything. Flush the toilet 500 times a day, it doesn't matter. It's carried to a place with pipes that are in place. We've got 5-inch pipes in the house. The use of those pipes is 2% of capacity, and run it to a place where we can then extract all the value from that paper, nutrients and energy. So where we can extract nutrients and energy, we do absolutely everything. And those microfibers will be extracted as well.
Well, thank you very much. If anybody has any more questions, please come and talk to them during the networking session after this. If we can all give a big hand to Paul Skillicorn and Manny Bannon.
Thank you.
And with that, on the screens, hopefully you'll see the events coming up. Paul, I need that. Thank you.
The clicker.
Yep. The next.
That's the vertical system.
Sorry to be running through your...
You go backwards.
There we go.
Yeah, there you
There we go. Okay. So, yeah, now you'll see the next events we have planned. If you're interested, please register and attend. Again, the events are all free and everyone's welcome. You'll also receive a feedback form via email from us. Please complete them. We do read them and try and adjust the way the presentations are held as a result of those. And with that, good evening to everyone who's joined us from home via YouTube, and if everybody could make their way to the network reception to continue the conversation. Thank you very much and have a good evening.